everyone. In this video, we're going to be talking about the results of intermolecular forces and what effect that has on physical properties of various substances. So you guys can follow along on page 5 of your packet of fun to fill in some notes as we go through this. So the first thing is adhesion and cohesion. And adhesion is the attraction of particles to solid surfaces. So for instance, if water spills on a table and I clean it up with a paper towel, it has an adhesive force between the water and the paper towel. So there's a force of attraction that occurs between the water molecules and the paper towels. Cohesion is the attractive force between particles for each other. So for instance, a water molecule feeling an attraction toward another water molecule. So think about how if you are in your car and you're waiting to pick a friend up from practice and it's raining outside and you notice that the drips of water that are on your car window tend to stick together. Those are cohesive forces of attraction. They are attraction of particles for each other. So adhesion is like an adhesive where you stick one thing to something else. Cohesion is when two molecules or lots of molecules of the same type stick together. This causes something called surface tension. And by definition, surface tension is a contractive tendency of the surface of a liquid that allows it to resist an external force. So you see this picture here. We have a bug that is standing on the surface of water. What ends up happening is that when you have the surface of water, the layer above the water is a gas layer. There's no more water above it. So there's that top layer of water that doesn't feel any attraction to whatever is above it because it's just a gas above it. So what ends up happening is that the top layer squeezes together a little bit. The top layer is a little bit more attractive to, those water molecules are more attracted to each other at that top layer than within the body of water because there's no other water above it to grab more attraction. So if we take a look at this little penny here, and we'll be doing a lab with this, but water molecules hold very tightly to each other on a penny because it's just gases around it. So those water molecules are feeling attraction only toward each other, that cohesive force, and it creates that surface tension on the surface of the penny. Now the reason that that exists is because water undergoes hydrogen bonding, which is the strongest intermolecular force that we have other than ion dipole force of attraction. There's also a video linked in your notes. It's this guy in space just kind of like playing with water, and you get to really see the forces of attraction there. So if you're interested in that, you can watch 1, 2, or all 5 minutes of it. And again, it's just linked in the notes. The next thing we're going to talk about is viscosity. So this side. Viscosity is the resistance of a liquid to flow. So basically, intermolecular forces either make things hard to flow or it allows things to be very easy to flow. If something is resistant to flow or difficult to flow, it has a high viscosity. If something flows very easily, then it has a low viscosity. So I want you to think of honey versus water. Think about dumping honey versus dumping water. Water splashes everywhere. It flows very easily. Here, I have this water bottle here. You can hear the water shaking around in my water bottle. It flows very readily, which means that it's going to have a low viscosity. It's not very resistant to flow. But something like honey flows a lot slower. It's much more resistant to flow, so it has a very high viscosity. Now, what does this tell us about their intermolecular forces? Well, if something is very resistant to flow, it means that it has a very strong intermolecular force. So I want you guys to write that down. Looking for a pen, but I'll just use my finger. So if something is very resistant to flow, that means that it has a strong intermolecular force. Versus something that flows easily or readily, that means that it has a weak intermolecular force. And that's why it's so easily flows past each other, because the molecules aren't as attracted toward one another than things with stronger intermolecular forces. It also says here, viscosity increases with stronger intermolecular forces and decreases with higher temperatures. So if we are to add energy, like heating up honey, we can break apart those strong intermolecular forces and make them flow past each other with more ease if we add that energy to them. The next thing we're going to talk about is volatility. And volatility is how easily a substance goes into the gas phase. And if something has a high volatility, it means that it evaporates very easily. If something has a low volatility, it's very hard to evaporate. Because of this, if something evaporates easily, it means that it goes from a liquid to a gas very quickly, which means that the intermolecular forces must not be that strong. So if something has a high volatility or it evaporates easily, or maybe you open up something and it's really smelly, that means it has a weak intermolecular force. And that's why you can smell it so quickly, because those particles are breaking apart, becoming a gas, and then you inhale it through your nose and you can smell it. If something has a low volatility, it's very hard to evaporate. So these would be things that don't smell very much. They have strong intermolecular forces, and that makes them difficult to evaporate. So maybe we don't smell something and we need to actually give something energy in order to force it into a gas phase. So something with a higher boiling point, for instance. If something has a high boiling point, then it is very difficult for it to turn into a gas. And so we have to give lots and lots of energy to it in order for it to separate into the gas phase. So things with high boiling points have strong intermolecular forces because it takes more energy to break those atoms apart, or those molecules apart from each other. Something with weak intermolecular forces would have a very low boiling point or evaporation point, and that means that it doesn't take very much energy in order to break apart those molecules and separate them to get into the gas phase. The last thing that we're going to talk about is capillary action. Now, capillary action is basically the way water moves through plants. So capillary action is the movement of water within spaces of a porous material due to the forces of adhesion, cohesion, and surface tension. Basically, water molecules do this. Because they feel an attraction toward one another, they flow up through plants, and this capillary action, basically you can see in this picture here, if you were to soak a white flour in a liquid that has red food coloring in it, eventually those petals would become red because the water flows up through that stem.